Hi everyone, I'm Yuki Yamagata, and I will present a work called The Finding Repeated Strings in Code Repository and its application to code clone detection. This is a joint work for Fabian Elbe in University of Nantes, Yuji Fujiwara and Katsuro Inoue in Osaka University. So we first introduce what is code clone and then show our go and non-go, and present our proposed method and preliminary evaluation. Finally, we present a conclusion and future works. Code clone is a similar code pair in code repository. Finding code clone is useful for refactoring and finding bugs in similar code, plagiarism detection, and understanding code evolution. Code clone is classified into the 4 classes based on its similarity, degree of similarities. Type 1 is a verbatim copy, but usually comment removed and new line normalized. Type 2, you can change the identifier names, and in type 3, you can remove or insert new statements. Type 4 is a code pair which has a functional similarities, but may not have any syntactical similarities. So our goal is to first try to apply a method from bioinformatics. And by this, we developed a purely language-independent code clone detection method. So it is easy to deploy in practice. Also, it is easy to implement and maintain because there's no parsing or no lexing involved. Also, we want to show that our method is useful to understand structures of large code repository. Also, we want to show our method has a practical speed and memory usage. On the other hand, we do not try to support complex types of code clone like type 3 or type 4. Also, we don't aim best precision or recall rate rather than try to develop a simple tool. Also, we do not aim best speed, memory usage, or scalability. So first, we propose a concept called a weak type 1 code clone. Weak type 1 code clone is a verbatim code in character level, including comments. So also, we do some normalization. We normalize a new line, tab, and success space into a single space. So our weak type 1 code clone is defined in fully language-independent way. Also, its normalization method is most useful to language with C or Java-like lexical convention, because in C or Java, you can change the location of new line without changing its meaning, the code's meaning. So we developed a tool called code repeat, which uses a fine rep set developed by Baum et al. To find a repeat strings in repository. So fine rep set uses first suffix array construction, and it achieves O(n) space and O(n) log n time. So our tool consists of a pre-processing stage and final rep set and post-processing stage. In pre-processing, we concatenate all files. Also, it generates the location table file and lines and performs some simple normalization. Then concatenate files is put into fine rep set, and we get a set of repeated strings in the repository. Post-processing phase, we generate the mapping to files and line to generated repeat strings and do some filtering and some split each repeat strings by file boundaries. Then we get output in JSON format. So this is a benchmark by using a well-known open source repositories: Python, OpenSSL, TCC, Firefox, and Android. We compare performance of code repeat with Duplo, CC5X, and Nika. We choose these two because they are widely used and they are representative of line-based, token-based, and syntax tree-based method. So in this table, we show that how long the processing takes. As you can see, code repeat has a competitive speed compared with other tools. Moreover, for Android, Nika and Duplo cannot process, while code repeat can process Android source code without any problem. This table shows the memory usage. As you can see, our tool code repeat has more memory usage than other tools. Still, our tool memory usage is within a capacity of modern personal computer. So this is a code example detected by our tool. As you can see, code repeat can detect the code clone in which the new line position is changed. Also, we find a large code clone in Firefox. So we found that Firefox has a different version of SQLite implementation. Also, SQLite implementation has a common code block in its source and header. This information is useful to maintain the Firefox repository. Also, we perform the benchmark with the Bitcoin base to evaluate the recall rate of our tools. As you can see, for type 1, code repeat and CC5X and Nika have almost same performance. Also, even type 2 has a moderate performance. Because type 2 code clone still have a common completely exact match between the two code clones. So so finally we discussed the conclusion and features. So our method, as we show, reasonably fast and memory efficient at scale. As we noted, it can process the whole repository of Android operating system. Also, it can find useful code clones to understand the repository structure, even it only detects the weak type 1 code clone. For the feature box, we need more evaluation like precision. Also, there are many algorithms proposed in the bioinformatics context, which has a better performance. So we want to try these algorithms to improve scalability of our tools. Also, we want to develop a visualization tool to help the developer to use our tools. So thank you for listening, and with any comments or questions.